Hi, Tony back with you. Just a quick video just to show me going through my jobs and rectifying the faults that the Safe Electric have pulled up with the single point of isolation and little things like that. As you can see behind me here, I've got a Sigenergy unit here. It's a big 3-phase 12 kilowatt system, and you can see all the isolators and power meters and everything there beside it. So I have to now go ahead and make a single point of isolation for this installation, so I'll show you the results. So that's our system there, and as you can see, this is a very large property, and we have 29 solar panels up there on the roof, and the sea is literally just over between the house and the tree over there. We're actually on an island just off the coast of Dublin, and that's why we have probably 80 to 90 kilowatt hours per day produced here. So up in the attic now, this is our rapid shutdown, our shunts, and they handle the DC current. Basically, you have here a fuse spur. It shouldn't have a switch on because it's not functional, but I've put a switch on. It's handy for this demonstration. You have your earths and your loops in there for your IR testing. You have to have an IR test. I'm still on the fence whether this is protective earth or functional earth, whether it should be pink or green and yellow, but anyway, they said 6mm green and yellow, so that's what we do. Right, rapid shutdown, and next to it here, I've just tapped in here and made a relay. I'll put the proper labels on in a minute. A relay for my gateway. So this sends a signal. It's live at the moment, so that means it's contacted this relay, and it's sending a low voltage signal over to the gateway, and the gateway receives a short circuit when this is powered up. So this is all of our B6 MCB in the fuse board. So when the fuse board's switched off, all of this will die like this. I'll just show you. But switching this off, and you can hear the clunk. And that's it. That's all of our 29 solar panels. Actually, there's some over the other side, so that's probably most of the panels anyway. Shut down and disconnected, and also this relay shut down, disconnected, and therefore the inverter now through the gateway would have received the signal to cut off. So over to the gateway, and a simple test here for voltage. Now I'm on the grid side of the inverter switch, and if you have a look at the meter there, 240.6 volts. Now if I move this down to the normal island mode inverter side, with now our disconnection occurred, we go down and we see the voltage, and we're at 1.5, a little bit of floating voltage there, so that's dead. It's not giving anything back out, and that's all because we installed a low voltage cutout on DI and ground over there, which goes back to that relay that I showed you before. So that's proved the system, inverter system, is shut down in a emergency. So an additional test here at the gateway, just to show you the earth and neutral combined DIN rail connector there on the end, and that's just going to a earth cable which is bolted onto our main earths there. So if we come up here now, I'm tested in, I'm plugged into a socket. I'm just going to press for a ZS reading up there, and we have, you give it a few seconds and it will come up something like 0.4, 0.5. Not too bad, 2.8, 0.28, sorry. And now if we try that test again, but by turning the grid off, that's the ESP supply out in the street, we switch that off, clunk, that's everything off, but you can notice we're all still powered up. Everything's still powered up here because we're on backup now, and we're going to just try the test one more time. Give that about 5 or 10 seconds, and it should be about 2, something like that, 2 ohms, but within our 2.4, hopefully. There you go, 1.73. So it's not as good as the ESP neutral to earth ground, but it's still adequate because I'm just plugged in on an extension lead on this, on the furthest socket away, and that's my maximum reading there. Thank you very much for listening. Finally, as a quick demonstration, here's our meter cabinet. As you can see, it's a nice big 3-phase 100 amp supply, and fairly substantial property. It's not that big, but it warrants 3-phase supply. We have safe isolation here, which the DNO has provided, and if I turn that off now, clunk, that's it. We've lost all of our power from the street. Hopefully, if we have a look now inside here, we should still be having power because we'll be on battery backup. Yeah, as you can see, the power's still on, the light's still on, everything's good, and I have my meter plugged in here to show you a ZS test on battery backup. Now this is just into a socket, as you can see there, and our maximum is 2.4 ohms that we're allowed, and this is without the DNO supply. Have a quick look at that now. Give it a few seconds. There you go, 1.5 ohms. So we're perfectly within safety parameters on battery backup, running off those two 8 kilowatt batteries over there.